Hello and welcome to yet another session of supply chain management. Uh, we are looking at the first module of this session, but in general in this session we are going to talk about supply chain coordination. What do we mean by coordination? Well, as we already know that, in our supply chain, there are multiple entities or there are multiple business entities who are collaborating with each other to fulfill the objectives or goals of the supply chain in terms of reaching the customer, whatever the customer wants, in fulfilling the customer's needs. And let me just take you back. Now, you might remember that right in the beginning when we were doing the overview of supply chain, we had talked about the goal of supply chain management, and that goal was that we wanted to maximize the what we call the supply chain surplus. Okay, and the supply chain surplus, you might remember, we had defined as the total value created for the customer minus the total cost incurred in creation of that value. And this supply chain surplus is a global, let us say, phenomenon, or a global quantity in terms of the fact that we are not looking at the profitability of local players. We are not looking at profitability of individual players. We are looking at the overall supply chain profitability, and we want to maximize the overall supply chain profitability. Why exactly do we want to do that? It will become very clear soon enough. Now, we talked about customer value. Now, measuring customer value has always been a problem, but we still need to measure it, and therefore the closest that we can get, can be the price. So we are approximating the value created for the customer by the price that the customer pays, taking note of the fact that the value can be slightly higher than the price being paid by the customer when the customer feels very happy and says, wow, what a bargain I have got. Or the value could be lower than the price paid by the customer, in which case the customer might say, I got cheated in this case. But just kind of ignoring those exceptions, we are equating the value with the price. Good. So let us discuss this coordination issue in the supply chain with the help of an example. In this example, we have a two-stage supply chain. By two-stage we mean that there is a supplier or a manufacturer supplying to a retailer, and these are the only two business entities that are involved in the fulfillment of the customer demand. Now, there are some data which we have here. So let us take a look at those data. Now, whatever item we are talking about, the variable production cost for that item is, let us say, $35 per unit. Okay, and the fixed production cost, as you can see on the screen, is $100,000. Okay, so these are the costs that the manufacturer entails. The manufacturer sells the item to the retailer at a price of $80, and we call this the wholesale price. This is the price at which goods get exchanged between the manufacturer and the retailer. The same item in the market is sold by the retailer for a price of $125, and we are also given a salvage value, which means that if there are items which are left behind after the demand has kind of, the demand cycle is over, you can, or the retailer can salvage those leftover items for a unit price of $20. Okay, so this is the basic data which we have in our case. Now, obviously, the question we are asking is that given this data, how much should the retailer order onto the manufacturer? And this refers to something that we have done in another session when we discussed single period inventory, and we talked about the optimal order quantity, and we said that the optimal order quantity really was determined by the critical ratio, involving the shortage and the excess cost. So in our example, let us go ahead. Before we do that, I completely missed out. There is a demand, of course, for that item, and that demand is, shown here on the screen. Now, two things we need to note about the demand. The first is that the demand is probabilistic, which, of course, is quite understandable. That it would be probabilistic. The second thing we need to note here is that in this example, the demand is a discrete demand. Now, what that means is that the demand can take only these values, 8,000, 10,000, 12,000, 14, 16, and 18,000. Okay, which also means that the demand cannot take any other value. So, if someone asks that what is the probability of the demand being equal to 13,000, for example, we would simply say that that probability is 0. And why 0? 0 because, for 13,000, so we have 8, 9, 10, 11, 12, 13. For 13,000, we don't have any probability because it's a discrete demand situation. So these are the two things that we need to note. The demand data or the distribution is shown both, in form of a bar chart as well as in the form of the table where we have the values. Okay, so there we are. We know the demand shown in the table. We simply picked it up from the previous slide, and we already have the data. So we are going to determine what is the optimal order quantity, and the optimal order quantity is defined as the quantity which is going to maximize the expected profit for the retailer, right? So, what do we need for that? We need to calculate our critical ratio, and let us look at the shortage and excess cost. Okay, so what is the shortage cost? It means if the retailer goes short, meaning that the demand is there, but I don't have inventory, I can't meet the demand, so therefore I have gone short. So demand has exceeded my quantity that I ordered. In that case, what do I lose? Well, if I can't meet the demand, then I lose the opportunity of making money had I been able to meet the demand. And what is that opportunity cost? The opportunity cost is that I would have sold one unit for $125, but then that unit I would have purchased from the manufacturer by paying $80, and therefore my margin is $45, 125 minus 80, and that is the margin that I stand to lose if I go short. So my shortage cost is $45. Okay, what is my excess cost? Excess cost is just the reverse of what we did just now, which means that I have now inventory which is left over, the demand is over, I can't sell anymore, and therefore what is my cost? And my cost is that that piece that I still have with me, I had paid $80 for purchasing it, but then I can salvage that piece for $20, and therefore my net loss for being excess is 80 minus 20, $60. Good. So what is my critical ratio? It is simply shortage cost divided by shortage cost plus excess cost, and if you put the values, you will get the ratio as 0.4285. Okay. Now, having calculated the critical ratio, how do we find out the optimal order quantity? To do that, let me take you back to our single period inventory problem. Now, I hope you remember that the critical ratio was basically equal to the probability that the demand is less than equal to Q star. So this was our critical ratio. And what is the probability that the demand is less than or equal to Q star? Well, it is the sum of the probability that X takes all values which is less than Q star till Q star. So therefore, you know, had the demand been normally distributed, we would have said, you know, if this is the normal distribution for the demand, if it was normally distributed, and let us say our Q star is somewhere here, then all we are saying is that my critical ratio is that area which you see there, which is shaded. Now, what does that area mean? That area means that all the probabilities of the demand taking any value which is less than or equal to Q star. So in our case, of course, we don't have a continuously normal distribution for the demand. In fact, we have, as you know, a discrete demand distribution. And therefore, what do we do for finding out our Q star? Well, if you can see here, we have added a third column where we are saying that what is the cumulative probability for the demand values? Well, how do we get this? Very simple. Cumulative probability of the demand being 800 or less is exactly this value, and then cumulative probability for the demand being 10,000 or less is either 10,000 or 8,000, so you add these two. Then cumulative probability of the demand being less than equal to 12,000 is 12,000, 10,000 or 8,000, so you add and you get 495, 720 and so on. You know, so we get the cumulative probability, and we are saying that our critical ratio, which is 0.4285, will lie where? You know, so if you come here, you will find that this is 0.495, so 0.4285 is just less than 495, and in fact 0.4285 lies between 0.220 and 0.495, and therefore we are saying that our quantity, order quantity, must lie between 10,000 and 12,000 units. Now, you must understand that there is no point in ordering a quantity which is in between 10,000 and 12,000, simply because that quantity, for that quantity, if the quantity is not 10,000, not 12,000, but something in between, for that quantity the demand is zero. Okay? So whenever we face a distribution like this, which is discrete in nature, and we calculate the critical ratio, always remember that please take the higher value for the order quantity. So in our case, between 10,000 and 12,000, the higher quantity is 12,000, and therefore we say that our optimal order quantity in this case is 12,000. Okay? And therefore, you know, by doing a very simple calculation, we are saying that the retailer should order 12,000 units for that item for which the data is given to us. Well, very fine. Now what? What I have here on the screen is the profit calculation for the quantity or the order quantity equal to 12,000 units. How did we do that? Well, this is something that we have seen earlier. We have the values of the demand and the corresponding probabilities. Now we have three columns: the retailer profit, the manufacturer profit, and what we call the channel profit. And let me just use the Excel to show you how we calculate these values. Okay, so I come to the retail profit. You can see here. Now, what will be the retail profit? The retail profit will be the retail revenue minus all the costs. So what is the revenue? The revenue is my price, whatever the retailer sells the product for. Now that price is given here, 125, okay, multiplied by the quantity that is sold by the retailer. Now what is the quantity that is sold by the retailer? You might remember that this will be the minimum between the demand and the order quantity, okay? So either you will sell 8,000 or you will sell 12,000, whichever is the lesser of the two, okay? So in this case, obviously, the retailer will sell 8,000. So that's our revenue. Anything else that the retailer gets? Well, let us first subtract the cost of the retailer. The cost of the retailer is fixed. It does not depend on the demand at all. It is fixed because the retailer has purchased each unit for 80. So that is my wholesale price, multiplied by whatever the quantity that the retailer has ordered, in this case, Q. Fair enough. So that is the cost. But will the retailer get something else? Well, yes. The retailer will, in fact, get back $20 for any item which is left in the inventory if the demand is less than 12,000. Okay? So the salvage value basically. So because the retailer will receive the salvage value, we put a plus sign and we say, what is that salvage value? Well, salvage value per unit is $20. So that's easy. I pick $20 multiplied by the quantity salvaged. Now what is the quantity salvaged? The quantity salvaged is going to be, when do we salvage? When the Q exceeds the demand. Okay? So the salvaged quantity is Q minus demand. So I say Q minus the demand. However, there is a problem in just putting it as Q minus demand. The problem is that if the Q is less than the demand, then the salvage value is 0. You don't salvage anything. But then, if I use this formula as it is, I will get a negative salvage value, which is not, reflecting the real situation. So what I will do is, I will put a function max here, the maximum of either this quantity or 0. Now I am fine, because if this quantity C3 minus B5 is negative, then the function max will pick up 0, which means that my salvage value is 0. Good. So I will use this formula, but I need to freeze the certain cell references because I need to drag it down. So let me freeze E $2. I don't want to freeze B5 because that is the demand. I freeze C $3, E $1, again C $3, G $1, C $3. I don't need to freeze B5 as I've already said, and I think we are done here. So let's press that, and then I drag it down. Wow, yes, we do have the retailer profit here. Now, one thing that you might notice and just verify that after we, for the demand equal to 12,000 and greater than 12,000, which means for all these cells, my retailer profit is constant. And the reason why it is constant is because, what are you selling? You are actually selling only 12,000. It doesn't matter. Even if the demand is 18,000, you are still selling 12,000. Even if the demand is 16,000, you are still selling 12,000, because that's the order quantity and the demand has exceeded the order quantity. Good. So we are done with that. Now let's come to the manufacturer profit. How much does the manufacturer, what is the revenue of the manufacturer? Well, the manufacturer receives $80 for every item that it sells. How many does the manufacturer sell? It sells Q star, which is 12,000 in this case. And then, so that's the revenue of the manufacturer. What is the cost? Well, the cost is, there's a fixed cost of 100,000. So I simply put that. And then there is a variable cost, 35 per unit. So 35 multiplied by 12,000. So that's the manufacturer profit. Make sense? Now here also, I will freeze my cell references. So C $3, C $1, C $2, and of course C $3. And when I kind of drag it down, obviously the manufacturer profit is not going to change at all in this case, because it depends solely on the order quantity, and the order quantity is fixed, and therefore the manufacturer profit does not depend on the demand at all. How do we find out the channel profit? Well, we simply do a sum of the retailer and the manufacturer profit. So as you can see, I have simply added the two cells, and then of course I drag this down too. So there you are. Now you might be wondering, how did I get the expected values? Well, the expected value is very simple. We take the probability cell, so we do a sum product of the probability array and the profit array, and that gives us the expected profit. So there we are. At 12,000, these are the retailer, manufacturer, and channel profit. Well, now the only question we need to ask here is that this quantity, order quantity 12,000, it is maximizing the retailer's profit, retailer's expected profit, but what about the channel profit? What quantity will maximize the channel profit? So let us consider this problem. Is the quantity that is going to maximize the channel profit different from 12,000, or is it the same? So let us try and answer this question. Okay, so this is the slide which you just saw straight away, taken from our Excel. Uh, so here we are saying what Q will maximize the channel profit, and for the channel, we are going to again do a calculation of our critical ratio. Now, let us understand this. What do we mean by the channel? The channel means the retailer and the manufacturer taken together. So you consider the retailer and the manufacturer together as one entity. That is our channel. So for this channel, what is the shortage cost? The shortage cost is the margin, that we could have made, but we fell short. We could not. What is that margin? That margin is the channel could have sold the item for $125. So the retail price still remains 125. So that is the inflow of money per unit. And what was the cost incurred? Because we have to subtract the cost for getting the margin. Now for the channel, the cost incurred per unit is $35. So therefore, for the channel, we are saying that the shortage cost is, what the channel loses is $90 if it is not able to sell one piece of that item. Because if that piece had been sold for $125 and by incurring a cost of $35 for making that unit, then the channel would have made a profit of $90, and that exactly is the cost of going short. Similarly, what is the excess cost? Which means that I am not able to sell, the demand does not exist. What is it that I lose by not selling? I have one unit, let us say. How much cost did I incur in getting this unit? Well, actually I incurred $35 for making that unit, because that's a variable cost, okay? So $35 is my cost incurred, but do I lose $35? No, I don't lose $35, because if there is something left over, I can always salvage it for $20, and therefore net my excess cost is 35 minus 20, which is $15. And therefore, with these values of shortage and excess cost, if you were to calculate the critical ratio, you'll find that it is 0.8571. How do we find our Q star? Exactly the same way as we had done earlier. So we look at the cumulative probability, and we find that 0.857 lies between these two values, and therefore between 14,000 and 16,000, we will pick the higher of the two, and Q star therefore is 16,000 units, which is very different from the 12,000 Q star that we had got earlier. Remember that 12,000 units was the retailer maximizing quantity, not the channel profit maximizing quantity. For maximizing the channel profit, the retailer needs to order 16,000 units. Now, fine, if that is the case, then what happens? So let us see what happens. How much is that channel profit, the maximum channel profit, when we order 16,000 units? So I show that on the screen here. How we got this exactly from the Excel that we had seen earlier. So let me take you back to the Excel. All I need to do is, instead of 12,000, I make this 16, manually make this 16,000, and there you are. The maximum channel profit is 101. I'm sorry, this is $1,015,550 dollars, which is, of course, as you can see, I have put the older value for Q is equal to 12,000. I have put the values now that we have got for Q is equal to 16,000, and we find that the channel profit is 11.5% higher than what it was for a quantity of 12,000. Now, 11.5% higher profit is a lot of money. When your profit margins are of the tune of 4%, 3%, 5%, 11.5% higher channel profit is mouth-wateringly high, And would the channel want to miss out on that opportunity of, getting that additional 11.5% of profit? Well, certainly not. Now, the only problem, of course, is here. The problem is here. And what is that problem? The problem is that earlier 12,000 units maximized the retailer profit that stood at $470,700. However, the moment you go to 16,000 order quantity, the retailer profit drops to 395,550. Now, why would the retailer accept this situation? In fact, the retailer just would not want to order anything other than 12,000. The reason is very, very simple, that is the quantity that maximizes the expected retailer profit. So here is a problem, and it's a very interesting problem. The problem is that we know that by ordering 16,000 units, the channel profit will grow by 11.5%, but we know that the retailer will not order 16,000 because, it reduces the retailer profit. And therefore, what mechanisms, what are the ways forward to deal with this problem? Very simple. At a very general level, we can understand that look at the difference between the earlier profit and the maximum profit, and you'll find that this difference is close to $100,000, $90,000. This difference is $90,000, and therefore we are saying that by ordering 16,000, you are going to earn, the channel as a whole is going to earn $90,000 more. Now, how much is the retailer losing? The retailer here is going to lose about maybe 7,000, yeah. So, I'm sorry, I'm not 7,000, 70,000. Maybe the retailer is going to lose 70,000, and whereas you are, as a channel, going to make 100,000. Okay? So the question is that since the overall gain is going to be more than what the retailer is losing, can the channel compensate the retailer for the loss and give maybe a little more than what the retailer was earning at Q is equal to 12,000? If that was possible, then it's a win-win game for everybody, because the retailer earns higher than what it was earning earlier, the manufacturer earns more, and as a channel, the channel earns more, maximizes the expected profit. So, interesting problem. Yeah, so here you have exactly what we just saw on the Excel. Now, what do we make, what would make the retailer order a quantity of 16,000 units? So, for that, the retailer is ordering based on the critical ratio, because the critical ratio corresponds to the Q that optimizes the retailer's profit. So where is the critical ratio? The critical ratio for the retailer is shortage upon shortage cost plus excess cost. Now if you look at the shortage cost, for the retailer is losing the margin if it goes short, and that margin is price that it could have earned minus the cost it paid, which is the wholesale price. Let us call that W. So this is P minus W. So shortage cost P minus W upon shortage cost plus excess cost. Now what is the excess cost? The retailer purchased at a cost of W, is able to salvage for G, and therefore the net loss for the retailer is W minus G. And simplifying, we get the critical ratio for the retailer is P minus W divided by P minus G. So let us again look at this. You know, P is the price, the retail price, which is $125 in our example. W is the wholesale price, the price at which the manufacturer agrees to sell to the retailer. P we already have seen, and G is the salvage value. Now, if you look at this entire thing, you know, this is the critical ratio for the retailer, and you want this critical ratio to increase. Why do you want it to increase? Well, you want it to increase because so that the optimal order quantity increases from 12,000 to a quantity of 16,000. Okay. Now, how do you make this quantity increase? Well, what exactly do you want the critical ratio to be? You know, how much should the retailer critical ratio be so that he agrees to order a quantity of 16,000? Very simple. The retailer critical ratio must be equal to the critical ratio for the channel, right? So that the channel maximizing, profit maximizing quantity becomes the profit maximizing quantity for retailer as well. Now, what is the channel critical ratio? For the channel, what is the shortage cost? Margin. What is the margin? Well, retail price still remains P, but what is the cost incurred? How much do we lose? You know, we lose the margin. So, what is the cost incurred? Cost incurred in this case is that $35 of variable cost. Let us call that C, and therefore the margin is P minus C. So, as a channel, the channel as a whole loses P minus C if it is not able to sell one unit. P minus C. What is the excess cost? Excess cost is I have incurred a cost of $35, which is C minus the salvage value, and therefore C minus G is my excess cost, and therefore we find that for the channel it is P minus C upon P minus G. So now we are saying that one way to solve the problem that we had just talked about is to do something so that the retailer critical ratio becomes equal to the channel critical ratio. Okay? Now, well, you know, if you were to equate these two expressions, you will find that, you know, the denominator is P minus G, denominator is P minus G, they cancel out. Numerator is P minus C, P minus W, and you equate them, you will say, well, the W has to be equal to C. Which means what? In our example, we are saying that the wholesale price has to be the same as the variable cost, which is $35. Now, if that is the case, then do you think the manufacturer will agree? Because manufacturer is selling a unit at the variable cost. What is the money made by the manufacturer? Nothing, absolutely nothing. You know, so the manufacturer will not agree to this. So the problem becomes even more interesting now. So how are we going to increase the retailer, you know, critical ratio and make it equal to the critical ratio faced by the channel? Now, this is something that we will deal with in the next couple of modules of this session.